When we solve equations by balancing, as is I'm highlighting here, balancing, what we're trying to do is we're trying to keep the equation the same on both sides, because equals means the same. So each side of the equation has the same value. Our goal in algebra is always to get the variable alone. So what we're going to do is slightly unbalance the equation and then rebalance it so we can get that variable by itself. So for instance, if we look at w plus 15 equals 32, the reason w is not by itself is because it has plus 15 next to it. So I can just undo that by subtracting 15 from each side. This is showing that balancing that we're talking about. If I do that, I'm doing the same thing to both sides, so it'll remain balanced. W ends up on this side, and if I subtract 32, if I take 15 away from 32, I end up with 17. So now I know the value of that W is 17. If I look down here at number 25, I'm going for balancing again. What I'm noticing is that the only reason P is not by itself is because it says P plus 29. So what I'll do is subtract 29 from both sides, and you notice I'm doing it from both. That's going to allow me to get the variable by itself. I get P by itself on one side, and I get 46 on the other side, and now I know the value of P is 46. You can pause it here and try the other two. If you look up at number 24 here, if I subtract 16 from both sides, I get G by itself on one side, and I get 21 on the other side, so I know that the value of G is 21, and I proved it by balancing both sides. If I look at number 26 here at the bottom, I see that the only reason that S isn't by itself is because it's plus 46. If I subtract 46 from both sides, I get S by itself over here, and I get 37 on the other side, so the value of S is 37. And in every case, what you should notice is that I've balanced by doing the same thing to both sides of the equation. If we try it with subtraction, it works the very same way. If we look at number 29, what we have is B minus 13 equals 21. Well, the only reason that B is not by itself is because you're subtracting 13 from it. The opposite of subtracting 13 is adding 13. If I do that to both sides, I get B by itself over here, and I get 34 here, so I know the value of B is 34, because 34 minus 13 is 21. If I look down at number 31, the only reason M is not by itself is because it's being subtracted 15. So I can undo that by adding 15 to both sides, keep it balanced. My whole purpose of that was to get M by itself, and it gives me 24 on the other side. So I know the value of M is 24, because 24 minus 15 is 9. If you want to try numbers 30 and 32, you can pause it here, then I'll go over it. For number 30, to get the variable by itself, I'll add 18 to both sides because it's D minus 18. If I add 18 to both sides, I get D by itself over here, and I get 55 on this side because 55 minus 18 is 37. Number 32, I see that Y minus 29 is 11. If I add 29 to both sides to undo that subtracting of 29, I do the same thing to both sides. I get Y by itself over here and 40 over here, because 40 minus 29 is 11. I can show that in all cases, I've shown balancing by doing the same thing to both sides of an equation. This works the same way for multiplication and division. As long as I can undo what's happening, I can get an equivalent expression. If I look at number 35 here, it's 7m equals 49. That means 7 times m is 49. And the way to undo multiplying by 7 is to divide by 7. If I divide 7m by 7, I get a single m. But I also have to divide the other side by 7 to get 7. And now I know the value of m is 7. Similarly, if I look at number 37, I see that 6n equals 48. I don't want 6 n's, so if I divide both sides by 6, I'll get n by itself here and 8 over here, because I know that 6 times 8 is 48. If you want to try the other two, You can pause the video here, then we'll go over it. For number 36, I see that 9W equals 108, but I don't want 9 W's, I want a single W. So if I divide 9W by 9, I get that single W, but I have to make sure I keep it balanced by dividing the other side also by 9. And that gives me a total of 12, because I know 9 times 12 is 108. If I do the same thing for number 38, I see that 11 times E is 77. If I divide both sides by 11, I don't want 11 E's, I want a single E. So 11 E's divided by 11 is just E, and 7 divided by 11 is just 7. I know it works because 7 times 11 is 77. What you'll notice for all of these is that we've balanced in every single case. Division works the same way. M divided by 9 equals 3. Well, I don't want M divided by 9. I just want M. So the opposite of dividing something by 9 is multiplying it by 9. It'll give me M all by itself, but I got to do the same thing to the other side. Gives me 27. I know that M divided by 9 is 3, so 27 divided by 9 is 3, so I know it checks out. For number 43 here, I see that it's B divided by 8. If I multiply this side by 8, and I multiply this side by 8, I'll be able to get B all by itself. And then 8 times 5 is 40. I know the value of B is 40 because B divided by 8 is 5, and so is 40 divided by 8. If you want to try the other two, you can pause the video here, then we'll go over it. You see that H divided by 7 equals 10. If I multiply this side by 7, I'll get H all by itself, and I multiply this side by 7, I'll get 70. I know that 70 divided by 7 is 10, so this works. For number 44, I see S divided by 9 is 7, so if I multiply both sides by 9, I'll get S all by itself, and 63 here. I know that 63 divided by 9 is 7. And again, similar to all the other ones, I've done the same thing to both sides of the equation to keep it balanced and equivalent. These are a little bit harder, but only because they involve fractions. They're really not that much harder. All I have to do is try to get the variable alone. If I look at number 51, I see that W minus 1/8 is 5/8. I want to undo what's happening there. The only reason W is not alone is because I'm subtracting 1/8. So if I just add 1/8 to both sides, I'll get rid of that minus 1/8, and I'm just left with a W. But I have to add 1/8 to the other side as well. That gives me 6/8, which can be reduced to 3/4. And you can see that I've, in both cases, done the same thing to both sides. If you want to pause this and try number 52, you can go ahead. If I see that n isn't alone because it's minus 1/10, if I just add 1/10 to both sides, it'll get rid of subtracting 1/10. Here I get n all by itself. Here I get 8/10, or I could call it 4/5. The value of n is 4/5, and as you can see, in both cases I've done the same thing to both sides to keep it equivalent. The last time that we're going to do here, there's two different kinds. Be a little bit challenging. The first one's not too bad. If we look at number 55, I see that the reason B is not by itself is because it's multiplied by 3. If I just divide both sides by 3, divide this by 3, it'll give me B. And I have to divide 2/7 by 3, but this is slightly more tricky. 2/7 divided by 3, I'm going to have to remember back to other chapters where we did division of fractions. 2/7 divided by 3 is the same as 2/7 times the reciprocal, which is 1/3. 2 times 1 is 2. 7 times 3 is 21. The value of this is 2/21. Down here at number 57, I see that 3/4 of x equals 24. Well, if I divide both sides by 3/4, I get x, and I have to divide this by 3/4 as well, because it's 3/4 times x, so it gets undone by being divided by 3/4. This one's a little more tricky as well, because now what I got to do is I got to take 24 and divide it by 3/4, but that's the same as 24 over 1 times the reciprocal of 3/4, which is 4/3. I can find some shortcuts here by factoring out 3 from the top and bottom of this equation. I end up with 32 over 1, or the value of x is 32. These require slightly more work. It's not enough to just do the same to both sides. You're actually going to need to do some work to make it happen. Why don't you try numbers 56 and 58, and then I'll go over them. So for number 56, I see that the reason s is not by itself is because it needs to be divided by 4 because it's times 4. So if I divide 4s by 4, I get s. And if I divide 8/9 by 4, dividing by 4 is the same as times the reciprocal. I can make this 1, and I can make this 2. So I end up getting 2 over 9, or 2/9 for this one. If I look at the bottom one, I know that 4/5 of a j is 28, and if I just divide both sides by 4/5, no problem here, I get j by itself. But it is a little more work to take 28 and divide it by 4/5. So instead, I'll take 28 over 1 and multiply it by 5 over 4. I'll use the reciprocal. This becomes 1. This becomes 7, and 7 times 5 is 35. The value of j is 35. What you can see, of course, is that I did the same thing to both sides of the equation to keep it equivalent, but I actually had to do a little work to make it come to look like how I expected it to look. So it is a little more tricky, but it's certainly something that you can do.